everyone. Welcome to this masterclass, which the name is Calculating Carbon Footprints in Construction, a 30-minute guide. We have today with us Xavier Puig. Welcome, Xavier. Thank you very much for being here today.
Thank you for inviting me to this event.
You're welcome. Well, Ziggurat is an institute of technology, and we have programs in architecture, engineering, and tech management. We have more than 20 years of experience, inspiring and educating the tomorrow's leader through innovative programs and trying to create a positive impact on society and in the planet. For this reason, we have here today Xavier Puig. He's from Barcelona, Spain, and he is the founder and director of Zirkel and accredited climate change consultant in Axio. I don't know if I am talking very well, though these names, but welcome, Xavier. The floor is all yours. If you want to share your screen, please.
Okay, yes, thank you, Melissa. Okay, let's. I'm going just to share my screen, just to give a short introduction about myself and about Zirkel. Can you see the presentation? Right?
Yes, perfect.
Okay. Well, just a few words. I am a consultant on LCA, life cycle assessment, and carbon footprint. I am the CEO of Zirkel. We are a consultancy firm that we make footprints, footprints studies of many processes, products, services, and so on. We have worked quite a lot on the construction sector, mainly developing EPDs and also working on the carbon footprints calculations for some buildings. So now we are going to talk about the topic of the carbon footprinting in the construction sector, and we will talk about buildings, and we will talk also about construction products, construction materials. So first of all, just to give a picture of the relevance of the carbon footprint of the construction sector. According to the United Nations, the built environment is responsible for more or less 40% of the global emissions worldwide. Okay, so it's a big number. And we have to also take into consideration that, according to some projections, the global building floor area is expected to double in 2060 in relation to 2020. So, in a scenario of global warming, and with taking into consideration that the contribution of the built environment in that global warming, and taking into consideration the projection of the development of the growing of the building sector in the worldwide in the next decades, it makes totally sense to all the professionals in the industry to understand what is the carbon footprint and to understand how to assess, how to calculate it, and also to understand how to implement measures to reduce this carbon footprint and to build less, let's say, or more environmental buildings, more environmental friendly buildings. Okay, so this is the general scenario. And now, if we focus a little, if we focus on what is the carbon footprint of the built environment of the building, we have to have to understand that there are two stages in the life cycle of a building and also of a construction product that contribute to the global warming, that contribute to the emissions of CO2. One concept is the embodied carbon. these are the embodied carbon is all the emissions that are related to the manufacturing of the materials of a building. Okay, this is the carbon that is embodied in a construction, in a building. Then this building, during his life, during his service life, this building is consuming energy. Okay, and the production of this energy is also emitting CO2. So we have, from one side, the embodied carbon in the materials of the building, and on the other hand, we have the emissions that are produced every day during the service life of the building, and that are related to the energy that that building is using. Okay, so the grouping of that is the life cycle carbon emissions of a building. So to understand a little bit more that, what we know is that nowadays roughly 70% of the emissions of a life cycle of a building come from the operations of that building. This is from the all the emissions related to the manufacturing of the energy that is consumed by this building, and roughly 25% emissions correspond to the embodied carbon in the materials of the building. So efforts for the last decades have been put on reducing the emissions of the operational emissions using strategies of efficiency and so on. So the expectations is that in the coming years, the proportion of the operational emissions will decrease because more and more there is an electrification of the energy, and also there is more and more use of renewable energies, renewable source of energy to provide energy to the buildings. So during the next years and decades, we will see a decreasing of the proportion of the footprint corresponding to the operational, and a growing proportion of the emissions related to the embodied carbon footprint. So in this slide, we can see this slide is a model of simulation, let's say, of a 30 years life of a building. In year 0, we have the construction of the building, okay? And in orange, we can see the embodied carbon that corresponds to the materials of the building. And in blue, we can see all the emissions related to the operational, the energy consumed by the building. So in the first year, when the building is constructed, 10% more or less of the emissions correspond to the emissions of the materials that have been that are in the building, and then normally these materials don't emit emissions, and we have a line of operational emissions. In year 15, in year 30, in that slide, it is modeled that there is a need of renovation and maintenance that implies the refurbishment, the manufacturing of new materials to replace the old ones, and that's you can see the orange bars in the year 15 and year 30. Okay, and the sum up in 2020 it will be 75% of emissions correspond to the operational, and 25% correspond to the embodied carbon. But in 2050, because of the improvement in efficiency and the spread of the renewable energies, the proportion of the embedded carbon will increase. So now let's see what are accounting standards that all the professionals that we work on the accounting of the carbon footprint, we have to calculate these carbon footprints. Okay. So in this slide, we have a sum up of the main standards. This is a type of pyramid where we have the international standards developed by the ISO. And I have put in this slide 4 standards that are key and are the base upon which all the rest standards are developed. So 29931, this is the framework to assess the environmental performance of buildings. 29930, this is the methods and the methodology to assess the environmental performance of construction products. 14040 and 14044, these are the methodologies to develop life cycle assessment of anything. Anything is process, product, service, whatever. And 21929 are the standards for sustainability indicators for buildings. So up on these standards, in Europe, CEN has developed standards for the European region based on those international standards. There are two standards that are key. One is 15978 for the environmental performance of buildings, and 15804 for the environmental performance of construction products and for the development of EPDs. And then on the top of this pyramid, we have the national and voluntary certifications like LEED, BREEAM, Verde levels in Europe, that they have specific methodologies, but all of them are in line, are in accordance with the European standards and the international standards. So now let's see, let's understand what is the life cycle of a building and what is the life cycle of a construction product. So in this slide, we can see the different modules or stages of the life cycle, right? And this is valid for both the building and the construction product. We have the product stage, okay, that begins with this accounts the emissions related to all the processes related to the raw material, the extraction of raw materials. Then the transportation of these raw materials to the manufacturer site and the manufacturing of the raw material. Okay, this is the product stage. Then the next module is the construction stage, and this accounts for the transportation of the product, construction product from the manufacturer to the construction site. This is A4, and then A5 this accounts for all the emissions related to all the processes involved in the construction and installation of the building. All the consumption of all the fuel by the machinery and so on. Then it comes the B stage that goes from B1 to B7. This is to account the emissions during the service life of the building or the material. Okay. In this service life, it is very important, the module B6, that is the operational energy that we said before, right? The operational energy is the consumption of energy made by the building or by the product during his service life. Let's imagine from the building perspective, B6 is all the energy that the building is consumed during his service life, let's say 50 years, okay? From the product perspective, B6 is the energy that the product consumes during his service life. For instance, concrete hasn't have operational energy during his service life, but luminaires and urban lighting, for instance, these products, the urban lights, they have a very big impact during his service life in B6, okay? So depending on the product, the impacts can be distributed differently on the different modules of the life cycle of the product. Then the end of life stage, the C, end of life, is the module C. And this includes C1, that is the demolition of the building. And here is all the emissions related to all the resources that are involved in the demolishing of the building, the transportation of the construction waste to the waste processing, that is C3. Waste processing is all the separation of the materials and so on. All these activities also emit CO2. And at the end, the disposal. Okay, disposal is all the emissions related to the disposal of the waste in the landfill. And at the end, there is one module that is module D. This module D really is out of the product system, of the product system of the building or of the material. But this is to account for all the benefits that, for instance, the recycling of the waste of the construction products, all the benefits that they produce, avoiding the manufacturing of primary materials, right? So when you recycle some materials, you are avoiding the manufacturing of a virgin of primary material, and this avoidance can be accounted as a benefit for the environment. And this is accounted here in the module D. Okay, now in this slide, I want to make a focus on more specifically how the carbon footprint is calculated. So the model is that we have one inventory of activities and processes. This inventory is made of quantity of fuel that is used to manufacture one product, or quantity of gas oil is used by the machinery that is used in the construction of the building, or quantity of specific raw material that is included in one construction product. All these processes or activities make the inventory of the product and of the building. And then for each activity or process, there is one emission factor, okay? And the multiplication of the activity by the emission factor gives the environmental impact that in the case of the global warming is expressed in kilograms of CO2. Here we have two examples. In the product stage, let's imagine that we have one building that is made of 100 kilos of steel and 50 kilos of glass. To calculate the environmental impact or profile of these materials, we have to multiply the quantity of steel and glass by the emission factor of the steel and the glass. In the case of the steel, the emission factor is 0.43, and in the case of the glass is 1.064 kilograms of CO2. And here at the end we have the total amount of kilograms of CO2 for this quantity of steel and glass. In operational energy, for instance, if we know that the building has a consumption of 10 kilowatts hour, and let's say that building is built, let's say in Spain, and in Spain we have the emission factor of the grid, the average in Spain is 0.30 kilograms of CO2 per kilowatt hour. So multiplying the kilowatts hour that is consuming the building by the emission factor, we have the 3 kilograms of CO2 of the operational energy of the building. Okay, so that's how the total amount of the carbon footprint of a building is calculated. Okay, once say that, now we will make a focus on EPDs. Okay, because they are becoming more and more important, and they are really the, let's say, the passports with the environmental profile, environmental information of any construction product. So we will have now a focus on the EPDs. What is an EPD? Well, an EPD is a type 3 label, is an environmental label that is descriptive. It provides the environmental profile of a product. It doesn't evaluate the performance. The EPD doesn't say if the product is good or not good environmentally, or is better than another one. It simply is a picture of the environmental profile of the product. This is verified by a third verifier. This provides the environmental profile for one functional unit or declared unit of a product. One declared unit can be 1 square meter of the product, one cubic meter, or 1 ton of the product. This is made like this to contribute to the comparability of different EPDs. So if we have 2 EPDs of different manufacturers of concrete, both EPDs will have the environmental profile of the product related, in both cases, to 1 ton of product. So the user of the EPD can understand very well what is the difference performance between the 2 products, because this environmental information is related to the same declared unit, in that case of 1 ton of product. And the validity of EPDs is for 5 years. Okay. In that ecosystem of the EPDs, we have 2 concepts that are important. One concept is the EPD program operator. The program operator is the entity that publishes the EPD and maintains the EPD. All the EPDs are public, and all of them are included in a database that is always open to everybody, and this database is maintained by the program operator. Okay. And one important role of the program operators is that they develop PCRs. PCR is a product category rule that is, let's say, it's like a cookbook or book of recipe of how the life cycle assessment of that category of products has to be conducted. This is important because of that, all products of the same category are assessed in the same way, following the same category rule. So this contributes to the comparison of the results of different EPDs of different products of the same category. Here in Europe, there is one entity that is Eco Platform. This is an umbrella organization that harmonizes how the different program operators develop PCRs and publish and maintain EPDs. So the role of Eco Platform is to gather together all the different program operators in Europe, program operators of EPDs of construction products, and to harmonize the way they develop PCRs and the way they publish information, just to contribute to contribute to a better comparability of the information of different EPDs developed by different program operators. So at the end, that topic of the comparability and the harmonization of the information in EPDs is very important to facilitate and to contribute for the users of the EPDs to be able to understand the different environmental profiles of different products. Okay. Now in this slide, I have put this chart. This is the core piece of one EPD. So this is the picture of the environmental profile of the product, and you can see that this is organized by you can see on the horizontal line the different stages of the life cycle of the product. This product stage, transportation to the construction site, construction from B1 to B7 is use phase of the product. C1 to C4 is the end of life and the benefits out of the system. And on the vertical, we have 13 environmental categories. We have global warming. This is the, let's say, the queen of the categories, of the environmental categories that we look when we assess the performance of a construction product. But not the only one. We have also ozone depletion, acidification, eutrophication of the water, and also eutrophication, terrestrial eutrophication, formation of smoke, depletion of resources, and water depletion. These 13 categories are mandatory for all the EPDs of the construction products. And of course, the most relevant of these categories, as I said, is global warming potential. And here we have the values for each category on the different stages. This chart gives a lot of information because when you read it, you understand in which stage of the life cycle you have the biggest impact. Okay. So just a quick picture on how the life cycle assessment is considered in BREEAM and LEED certifications. So for the life cycle assessment of a building is taken into account in LEED and BREEAM certifications. Both certifications give points and credits if the project includes the life cycle of the building. Okay, LEED gives 3 points and BREEAM gives up to 9 credits. Also, LEED and BREEAM they give points if there are in the project there are products with EPDs. In that case, if there are 20 different products with EPDs for both for LEED and for BREEAM. In that case, they give more points to the project if it includes products with EPDs. So now, just to go to the end of the presentation, we will see 2 real cases of life cycle of a building and also of EPDs. So starting for the life cycle of a building, here at Zirkel we conducted an LCA comparison between 3 types of buildings. It was one building of 152 square meters, service life of 50 years. And we modeled the carbon footprint of the building, built in a steel frame, built in wood frame, and in precast concrete. And we wanted to see what was the carbon footprint of the same building built with different construction systems. So the result of that study gave us that the construction with wood had the lowest carbon footprint, 422 kilograms of CO2 per square meter, against 773 for the steel frame and 1070 for the precast concrete. Okay. Here you can see the split of the carbon footprint along the different stages of the life cycle of the building. Okay, in the case of the wood, in case of the precast concrete, you can see that the impact in the stage of materials of the manufacturing of the concrete is really high. And it happens also in the case of the steel frame. The biggest part of the carbon footprint of the building is located in the manufacturing of the steel. Okay, and now we are going to see in detail some EPDs. And I want to provide some key concepts related to the EPDs. One is the product category rule. Okay, we have already talked about that. Well, the product category rule is the methodology that says how the life cycle assessment has to be conducted. And the standard 15804 is the base of the life cycle assessment for construction products. We have also complementary product category rules, CPCR, okay, that these are specific category rules that complement the generic one for building materials. Here on the left side, this is one extraction of one EPD of precast concrete product, and you can see that this is extracted from the EPD. This is the core standard is AN 15804, and then we have complementary category rules for concrete and concrete elements. This is one extraction of one EPD of one smart locker. Also, the core standard is the 15804, and it has specific complementary category rules for furniture. And then another key concept that we have already mentioned is the functional or declared unit. And this is the measure to which the environmental profile of the product is related to. So the environmental profile is related, in the case of the precast concrete, to 1 ton of product. In the case of wooden panels, to 1 meter cubic of product. Okay, and that's the declared unit, the quantity of a construction product for use as a reference in an EPD for an environmental declaration based on 1 or more information modules. And then, in the case of glass wool, this is extracted from an EPD of that glass wool. The functional unit is that providing a thermal installation of 1 square meter of product with a thermal resistance during 60 years. So, in that case of the glass wool, the environmental performance is related to that functional unit. Okay. One third concept important to understand in an EPD is the reference service life. Normally, the reference service life of construction product is 50 years, but not always. Okay, you can see for the concrete, for the wood panels, for the glass wool is 60 years. And this concept is important. And here we have an example. Just imagine that we have product A and product B, that they are made with the same technology. They accomplish the same function, and they have the same declared unit, okay? And they have the same global warming potential. It is 100 kilograms of CO2 for the whole life cycle for product A or for product B. And apparently they are the same. They have the same environmental profile. But it happens that product A has a reference service life of 50 years, and product B has a reference service life of 30 years. If we apply the carbon footprint per year, we can see that product A has 2 kilograms of CO2 per ton per year, and product B more than 3 kilograms of CO2 per year. And this is because the reference service life of product B is shorter than product A. So when you compare EPDs, you have to pay attention to the reference service life of the product. And just to finish, you have to pay attention also to the system boundaries, because not all EPDs encompass all the stages of the life cycle. Here we have two examples. On the left side, we have the results of one EPD that considers all the stages of the life cycle from A to D. And here you can see the table of the results with the global warming with values in all the stages. Where is a 0? This is because the result is 0, but the environmental profile has been assessed for C1, also for B3, and the result is 0. On the right side, we have that in that EPD has considered also from A1 to A5 and for C, but hasn't assessed the environmental profile in B, in the use phase. So you can see that the results for per functional unit are for A1 to A3, A4, A5, and then C and D. So normally you can have the inclination to sum up all the values of the life cycle to have the one single value, the carbon footprint, total carbon footprint of the life cycle of the product. But you have to pay attention for what is the span of the life cycle that is considered in the EPD. It would be unfair to compare the environmental profile of two products for one that is considering the full lifespan from A to C, including B, and another product only accounting for the carbon footprint of A and C. So you have to pay attention to how many life stages of the life cycle is considered in the EPD. So until here, the presentation, I've been very, very quick because I wanted to talk about many things. And okay, that's done from my side.
Thank you very much, Xavier. It's a very interesting masterclass, and it's such a quite important subject. I think for nowadays is we need to talk about that. It's very important. So let's we have also two questions. I will do the last one first because I think that is related with this last subject. So the question is from David Ryan. Thank you, David, for being here. And the question is, are stage C and D of the building life considered during the life cycle analysis case studies?
Okay, the life cycle analysis case studies. I guess okay. If you are referring to the case studies that we have seen in the presentation, yes, they were included in the study in the life cycle. And in general terms, when anyone conducts a life cycle study of a building, the standard way to proceed is to include all the stages, also C and D. I would say that D is not so. Let's say is not very often is calculated the stage D when you assess the carbon footprint of a building. C, yes. And D, not so much, because D is difficult really it's very difficult to understand what are the benefits of recycling all the different materials that are in a building. And normally the people, what they want to know is the real impacts of the building. And that's the main goal of the study. And that's why module D generally is not considered. But yes, it should be A, B, and C, these three stages should be considered in the study.
Okay, thank you. We have a question from Renata, and she's asking, how does understanding the carbon impact of construction materials influence in the choice of the materials in the project?
Okay. Okay. Okay, that's a good question. As far as I know, what I see here in Spain is that the environmental information in EPDs until a few years, until now, it was people wanted to have EPDs because for some projects was mandatory to have the EPD. Okay. But the purpose wasn't to check and to compare the environmental performance of different products for the building. But what we can see here in Europe is that, for instance, for the public procurement, it will be in the short term, in the next years, for the public procurement, the authorities in Spain will, in Europe, will set a minimum performance, environmental performance of the product. So if you are a manufacturer and you want to go with your product to a public public procurement, if you don't reach minimum environmental performance with your product, you will be penalized and probably you will not enter into that project. That's one. Second, there are architects and consultants and consultants that that when they start to define the first draw of the building, and they start to assess the performance, the environmental performance of the building, and they use EPDs to understand how will be the environmental profile of the building in the initial steps of the project, and they start to take decisions. For instance, if using concrete or steel or wood, based on that information that is given on the EPD. So more and more, the environmental profile of the products is being taken into consideration for architects and also, as I said, for the public tenders. And it will be more and more it will be considered as element for making decisions.
Okay, thank you. I have put here the QR code for our program in postgraduate program in sustainable architecture and construction, that we also we have this kind of subjects. So if you want, guys, as Andrea Silva is asking for courses more practical than theoretical, just text me. We can help you to find one course regarding this subject. And we have here a last one from Yasser Gam. What is an easy to use software to run LCA?
Okay. To running LCA for building, the one that I know is one-click LCA. Okay, and then for doing LCAs for products, there are many. One-click LCA, for instance, and others like Cima Pro, Gavi. OpenLCA also. This I would say these ones.
Okay, just well, we don't have more questions, but we will share all this presentation next week by email. So just we keep in touch for this record, so we can see you guys see all this presentation again. And just if you want to have some contact with me or with Xavi, just text us and we will be pleasure to answer more questions. Thank you very much, Xavier, for being here. Oh, let's see. I think that, yeah, thank you. Thank you again for your time, for all this important class. And thank you for everything. We will be here with us and we keep in touch. Thank you very much.
Thank you, everybody. Thank you, Marisa.
Bye bye. Bye bye.